Hi, Mark T the Handyman here. Today we're going to take a look at this Lennox high efficiency furnace and its sequence of operation. We're also going to give you a couple of pointers on how to troubleshoot it if it goes down. One of the things I want to point out before we get started is this little sight glass right there. Beyond that sight glass is the control panel. And on the control panel, if there's a problem, there's a blinking LED with a code that tells you specifically what the furnace went down on. If for some reason you shut the power off before you take that panel off, you'll lose the code because you'll reset it. So what you want to do is you want to look to see what the code was. Look at the control panel sheet that is on one of these doors or in your owner's manual, and then you can narrow it down to where the problem is, and it'll really make things a lot faster. Before we get started on our sequence of operation video, I'm going to go through a couple of components on this Lennox high efficiency furnace. First, we have a 24 volt two-stage gas valve. It has a low stage and a high stage. Now we go to the in-shot combustion burners. In-shot burners are pretty consistent with most high efficiency furnaces. Now on the far right side here, we have a hot surface igniter. That's our igniter. And then on complete opposite side of the burners is our flame sensor. You can see the top of the flame sensor right there. And this is the combustion burners again. This is a 10-year-old furnace, and we've lived here for about 3 years. Next, we have the high stage pressure switches. And right next to them with the two blue wires there are the secondary limit control, the automatic reset. And then the other side, we have the low stage pressure switches. Next, we have the two-speed inducer fan motor, or the induced draft fan motor. And you can tell that it's a two-speed because it has an extra wire. That red wire is extra. Normally you would have a white and a black and a green, and now you've got that red wire in there. Now we go all the way to the top, and we've got a flame rollout switch. It's a manual reset. And right behind that, you can't really see, it's kind of below to the left there, is a primary limit switch. On the other side, we have another rollout switch, which is also a manual reset. It's got that little red button on the side. Now we go to the two-stage furnace control board, and then we have the 24 volt transformer. And there's the blower motor compartment. That is a multi-speed direct drive blower. We can't really see the blower there because it's inside the blower assembly, but there's a capacitor for it. Next, we have a door switch. I put tape on that so we could actually do this test with the door off. Normally that switch, if you open that door, it automatically will shut off the unit. So that's why we have tape on there. This furnace has a direct vent application, which means we have the combustion air supplied from the outdoors through the PVC pipe. Then it goes into the combustion chamber, and then the exhaust from the combustion goes through this PVC pipe that takes it to the outside. So we got air coming in and then leaving through PVC pipe. And that's pretty much everything you have within the furnace compartments, the fan compartment and the combustion compartment. To get our furnace sequence started, I'm going to turn the thermostat to call for heat. Once a furnace circuit board gets the call for heat from the thermostat, it will begin the next sequence, which is to turn the induced draft fan motor on. When the induced draft fan motor comes on, it begins to purge the combustion chamber from any gases that may be left over or natural gas that has leaked out from the gas valve. Once the pre-purge task has finished, the control board will energize the hot surface igniter. After the couple of seconds of the igniter being on, the circuit board will energize the 24-volt gas valve. The hot surface igniter will go off simultaneously as the gas ignites on the burners. If the flame sensor senses there is a flame, the burner will stay on, but the blower motor will not come on until the heat exchanger is warm enough to send warm air to the house. The burners will stay on until the thermostat is satisfied. After the burners are turned off, the blower motor will continue to run until the heat exchanger has cooled down, all along sending warm air to the house. So that was a brief sequence of operation for this Lennox high-efficiency furnace. What I would like to do next is to show you a couple of furnace failure situations. But before we get started on that, I want to point out that so far on this video, I have removed the combustion chamber cover to give a better view of what is happening in the burner section. Just thought I would point that out. Okay, let's get started. So the first thing I'm going to do is I'm going to turn the furnace on, and we're going to watch the furnace go through a starting cycle. First, the induced draft fan motor will come on. Next, the glow igniter will be energized by the circuit board. The gas valve will open, and now we have combustion in the combustion chamber. Now I'm going to turn off the gas. The first simulation is the flame sensor was not sensing a flame, and the second simulation is if the gas valve failed to open. Both of these failures will give the same failure code. Either way, the control circuit board will not see the flame signal and will immediately de-energize the gas valve and try to restart the cycle. Once again, the surface igniter will be energized. If you listen closely, you can hear the gas valve being energized. But since we have the gas valve shut off, the control board will notice that there is no flame and shut down the system. After several attempts, the circuit board will give this code: 1 LED flash and then 3 LED flashes. Let's turn the gas back on. This time, the surface igniter lights up the natural gas and the heating cycle can continue. Next, I'm going to disconnect the surface igniter to demonstrate what could occur if your surface igniter is not functioning. The control board will notice that it does not have continuity through the surface igniter, and after a short period of time will shut the system down and display an alarm code at the circuit board. The code is 4 LED flashes and then 7 LED flashes, which is igniter circuit fault, failed igniter, or triggering circuitry. Next, we are going to pull off the hose that senses the air pressure when the induced draft fan motor comes on. The pressure control switches are normally open and close when they sense an induced fan motor has been energized. If the pressure switch does not sense that the fan is running, that can indicate several different things may have taken place. Either the inlet or outlet combustion PVC pipes are blocked, which would mean you need to clear the obstruction. Another cause would be the hose on the pressure switch has come off, or the induced draft fan motor has failed, or maybe the pressure switch has failed. Even though the fan is running, the circuit board doesn't sense that, so it will run for a short period of time, but then it will shut the induced fan motor off and give us a code of 2 LED flashes and then 3 LED flashes. I didn't feel like it was necessary to do the high side because it is the exact same process and the exact same code, except it will say high pressure failure. Well, we came up with a couple of failures that will give you a code on your circuit board, but there are many more failure codes, as you can see. In my opinion, the code failures that we talked about are certainly within the top 5 service calls for furnaces. I hope this video will give you a little more insight into your furnace sequence of operation and some possible failure codes. If you like this video, give me a thumbs up or a like. If you want to see more of my videos, please subscribe to my YouTube channel. Thanks for watching.